Okay, let's unpack this. Imagine you're building a game, right? Specifically one with really satisfying melee combat.
Yeah, not just, random button mashing.
Exactly. You want that feeling of connecting multiple hits, a smooth sequence, maybe it builds momentum, ends with something cool, a multi-stage combo system.
Right.
But taking all those separate pieces, the visuals, the animations, the player hammering the button, the actual game rules about damage and making them, well, work together smoothly, that's a classic challenge.
Yeah.
Can get pretty complex.
Oh, absolutely. On the surface, you might think, okay, just play the next animation when they press the button again. Simple.
Uh-huh.
But, you run into problems fast. Like, how do you define the exact window of time the player has to hit the next button?
Yeah, the timing.
What if they press it too early or too late? How do you trigger the effects, like dealing the damage or applying a status effect right at the perfect moment in the swing?
And how do you manage all that state, all that timing, without ending up with just, well, spaghetti code? That giant tangle of blueprint nodes or lines of code.
We've all been there. That tangled mess.
Been there, definitely done that.
I did, yeah.
And that complexity, that's exactly why this deep dive today is, I think, going to be super valuable. We've got this really detailed step-by-step guide right here. It lays out a clear A to Z path for putting together a solid multi-stage melee combo system.
And importantly, it does it using a specific framework in Unreal Engine, one that's really showcased well in Lyra.
Ah, Lyra. Unreal sample game project, one that shows off best practices.
Exactly. And the framework it uses is the Gameplay Ability System GAS. You'll hear us mention GAS a lot.
Right, yeah.
It gives you this really solid foundation for defining actions, what they cost, their effects, how they interact with everything, building something complex like a combo on top of GAS like this guide shows.
Right.
Well, it gives you organization, scalability, network handling, stuff that's hard to get right otherwise.
Makes sense. It's like building on bedrock.
It's not the only way, obviously, but it's a very Unreal Engine Lyra way. It leverages the tools they provide.
Gotcha. And our mission for this deep dive, it's really tailored for you listening. Maybe you're a junior dev, just getting into game systems.
Or maybe you're experienced, but, totally swamped. Juggling tasks, listening to this in the background.
Right. Trying to get the gist quickly. So, whatever your situation, we're going to take this guide, break down every step, pull out the key info, explain the why behind it.
The crucial bits.
And make sure that by the end, you walk away with a really solid, concrete understanding of exactly how this kind of system gets built, piece by piece, using Lyra and GAS as the foundation.
Yeah, we'll cover the whole process.
Yeah.
From, prepping your animations so the game can control them dynamically.
To wiring up the player's input so it knows if it's starting a combo or continuing one.
And getting that core logic inside GAS to manage the sequence, react to animation timing, and decide, do you get that next big swing or not?
It really touches on animation, input, core gameplay programming, all integrated.
That's the goal.
All right, let's dive in. So before the guide even gets to step one, it sets the stage. It tells you what you need to have ready before you start. You're not starting from a totally blank slate.
Right. It assumes you're building on a foundation, which makes sense if you're using something like Lyra. Lyra itself gives you a lot of the boilerplate stuff already done.
Okay, so prerequisite number one.
Yeah.
You need a Lyra-based project already up and running. That's your starting point.
Makes sense.
Then you also need a basic player character blueprint. The actor that actually does the swinging.
Yeah.
In Lyra, that's often something like BP player character, or maybe one you made based on their character.
Yep, the character needs to exist.
And this is a big one. You need an existing, basic, single melee attack gameplay ability already set up.
Yeah.
The guide calls it GA player melee attack.
Right. This ability probably just handles activating, maybe playing one animation clip, applying a simple damage effect once. We're not building the combo ability from zero. We're going to change this existing one.
So you already have an ability that does one hit, but not a sequence. Got it.
And finally, the raw materials, the art assets. You need, according to the guide, at least 2 or 3 distinct sword swing animations.
Like swing 1, swing 2, swing 3 as separate files.
Exactly. These are just your animation clips. The guide isn't about making animations, it's about using the ones you have.
Okay, so having those pieces, the Lyra project, the character, the basic single hit ability, and the animation clips means you can focus just on the system part, the sequencing, the timing.
Precisely. You're not bogged down setting up the basics. It's focused.
Cool. Foundation established.
Yeah.
So step one, this is where we take those separate animation clips, swing 1, swing 2, swing 3, and turn them into something the game can actually control as a sequence. It's all about making the combo animation montage.
The animation montage, yeah. It's absolutely key for this approach in Unreal. Think of it like a special container for your animations.
Okay.
You take those individual swing assets and you basically stitch them together inside the montage editor. You put them onto one long timeline.
Right, like editing video clips together. You have swing 1, then swing 2, then swing 3, all lined up end-to-end on one track.
Exactly like that. And in Unreal, you start with your first clip, say swing 1, right-click it in your content browser, choose Create Anim Montage.
And give it a clear name, like AMS Sword Combo.
Perfect. That creates the montage asset, initially just containing that first swing.
Then you open that AMS Sword Combo asset, and inside that editor window, there's an asset browser. You find your other animations, swing 2 and swing 3, and you just drag them onto the main animation track in the montage timeline right after swing 1. So swing 1, then swing 2, then swing 3. Now they play sequentially.
Yep. If you hit play now, you'd see all 3 swings play out one after the other, but that's not enough for a combo system, is it?
Right, because you need to be able to jump between them based on player input. You don't always want to play all 3.
Exactly. And that's where the really critical part comes in. Montage sections. These are basically named bookmarks on your montage timeline.
Bookmarks. I like that. So your code could say, jump to the Attack 2 bookmark.
Precisely. The guide shows you how. In the montage editor, there's a specific track, usually near the top, called montage sections.
Okay.
You right-click on that track, right at the very beginning, frame 0, choose New Montage Section, and you name it, logically, Attack 1.
So that marks the start of the first swing.
Then you scrub the timeline forward to the exact frame where your Swing 2 animation starts playing. Right-click the Montage Sections track there, create another section, name it Attack 2.
And do the same thing for where swing 3 begins, naming that section Attack 3.
Exactly. So now your AMS Sword Combo asset isn't just one long animation anymore. It's one long animation with these clearly labeled entry points. Attack 1, Attack 2, Attack 3.
Ah, okay. That makes a huge difference. Instead of trying to juggle 3 separate animation plays in code,
Which can get really messy, especially with timing.
you just have this one asset, the montage. And your code or blueprint just tells it which named section to play or jump to.
Right. All the visual timing, the sequence itself, it's all bundled neatly inside this one montage asset. It becomes the visual backbone of your combo. Much cleaner.
Definitely cleaner. Okay, so we've got the visual sequence ready with jump points marked using sections. But like you said, animations are just visuals. They move the character, but they don't by themselves trigger damage or tell a game, hey, the player can press the button now for the next hit.
Correct. For making the animation interact with the actual gameplay logic, you need special markers on the animation timeline itself.
And those are animation notifies.
Animation notifies, exactly. They're like little events or states you can place at very precise points or even over durations within the animation timeline. And they can trigger blueprint logic or send signals to your game systems.
Okay. And the guide says for this combo system, we need to create 2 custom types of notifies, not just the basic built-in ones. We need to make our own.
That's right. The first type is what's called an AnimNotifyState. Keyword there is state.
State, okay. Not just an event.
Right. Unlike a regular notify, which is just a single point in time, like a pinprick on the timeline, a notify state has a beginning and an end. When you place it on the timeline in the editor, it looks like a little yellow bar that you can stretch out over a certain duration.
Oh, okay. A duration. And what's the purpose of this specific custom one we're making?
Its job, according to the guide, is to represent that crucial combo window. It literally tells the game, hey, for the duration of this yellow bar right here in the animation, the player is allowed to press the attack button again if they want to try and advance the combo.
The input window. Got it. So how do we make this thing?
You create a new blueprint class. When it asks for the parent class, you search for AnimNotifyState.
AnimNotifyState. Okay.
And you give your new blueprint a good name, something like AnimComboPeriod, ANS for AnimNotifyState.
Makes sense. And what goes inside this AnimComboPeriod blueprint?
Inside, you need to override 2 specific functions that the engine calls automatically. ReceiveNotifyBegin and ReceiveNotifyEnd.
Begin and end. So what happens when the animation hits the start of that yellow bar, and what happens when it leaves?
Exactly. In the ReceiveNotifyBegin graph, you do a few things. You get the mesh component playing the animation that's usually an input pin on the node. From the mesh, you get its owner, which is your character actor.
Right, the character doing the swinging.
Then you cast that owner reference to your specific character blueprint, like BP player character. And if that cast succeeds, You grab a Boolean variable that you need to create on your character blueprint. Let's call it bInComboPeriod.
bInComboPeriod. Like, is the character in the combo period right now?
Exactly. And in receiveNotifyBegin, you set that bInComboPeriod variable on the character to true.
Okay, so animation hits the start of the yellow bar. Boom, the character now knows input window is open.
Precisely. And then logically, in the receiveNotifyIn function, you do the same thing. Get meshcomp, get ownerCast to BPPlayer character. But this time, you set bInComboPeriod back to false.
So as soon as the animation playhead moves past the end of that yellow bar, window closed.
Window closed. That simple Boolean on the character, flipped on and off directly by the animation timeline via this custom notify state, becomes the gatekeeper. It's how the input logic later knows if a button press should even try to advance the combo. It's a direct link animation timing deck gameplay state.
Very cool. Okay, that's the first custom notify, the state for the window. What's the second one?
The second one is a more standard AnimNotify. This one is just a single point in time, like placing a marker at one specific frame.
Not a duration, just an instant. And its purpose.
This one's purpose is to trigger a specific gameplay event at that exact moment. Typically, this is used for things like applying damage right when the sword visually connects, or maybe triggering a particle effect or a sound.
The impact moment.
Okay.
How do we make this one?
Similar process. Create another blueprint class, but this time search for and inherit from just AnimNotify.
AnimNotify. Got it.
And you might name this one something like AnSendGameplayEvent, and N for AnimNotify.
And is a gameplay event.
Okay.
And what logic goes inside its receiveNotify function?
Inside receiveNotify, which fires when the animation hits that single marker, the logic is, again, pretty specific to using GS. You get the mesh component, get its owner, cast to your BPPlayer character, same as before.
Okay.
But then from the character reference, you need to get access to the component that handles all the GAS stuff for that character. This is the ability system component, or ASC for short.
ASC, right. The heart of GAS on the character.
Every character using GAS has one. You get the character's ASC reference. And from the ASC, the guide tells you to call a very useful function. Send gameplay event to actor.
Send gameplay event to actor. Okay, what does that do?
It basically broadcasts a named event message from that actor to its own ability system component. Other things could listen too, but primarily it's a way for notifies or other parts of the game to send a signal directly into the character's GIS brain.
A signal. And how do you specify what signal?
Ah, that's the crucial event tag pin on the send gameplay event to actor node. It needs a unique identifier, like a code word, for this specific event. And that leads us directly into the next step, gameplay tags.
Okay, but just to recap these notifies, we have AnimComboPeriod, the state, controlling the bInComboPeriod Boolean on the character for the input window, and we have AnimSendGameplay event, the single point event, which calls send gameplay event to actor on the ASC using a specific tag.
Exactly. These are your timing tools. You're basically letting the animation timeline itself drive when these gameplay relevant things happen, which is super flexible. Animators can adjust the timing without needing code changes.
Nice. Okay, so that code word, that event tag, step 3, defining the gameplay tag.
Right. Gameplay tags, if you're working with GAS or Lyra, you'll see these everywhere. They're incredibly important.
What are they, fundamentally?
They're essentially just hierarchical names. Think of them like folders and files in your computer, but for game concepts. You might have action.ability.melee.attack or state.debuff.poison.
Just names, structured names.
Exactly. They're not like heavy objects or actors. They're just lightweight identifiers that are registered centrally in your project.
And GAS uses them for everything.
Pretty much. Identifying abilities, effects, states, inputs, damage types, and crucially for us right now, events. Their power is that different parts of your system can communicate or react based on these shared tags without needing direct hard-coded links to each other.
Ah, makes it more modular, decoupled.
Totally. Very data-driven. So to create the specific tag we need for our damage event notify, you go into the Unreal Editor at -project settings -gameplay tags.
Okay, the central tag manager.
Yep. You click Add New Gameplay Tag, and the guide suggests something clear and descriptive. A good one is event.montage.combo.
Event.montage.combo. Tells you it's an event from a montage for the combo system. Makes sense.
Once you've added that tag and saved your project settings, you just need to go back into your AnSend Gameplay Event Notify blueprint.
The one we just made.
Right. Find that Send Gameplay Event to Actor node, and on its event tag pin, you select the event.montage.combo tag you just created from the drop-down list.
Okay, so now When that notify is hit on the animation timeline, it fires off the send gameplay event to actor function, broadcasting the specific tag event.montage.combo through the character's ASC.
Exactly. And the beauty is, the ability logic, which we're about to wire up, doesn't need to know the name of the notify blueprint and send gameplay event. It just needs to know which tag to listen for.
Event.montage.combo.
And the notify doesn't need to know which ability is listening. It just sends the tag.
Yeah.
They agree on the tag. That's the contract. If you rename the notify later or make a different notify, send the same tag, the ability doesn't care. It just listens for the tag.
That's really flexible. Okay, I see the power there. Right, so we have the visuals in the montage, the timing tools in the notifies, the communication channel via the gameplay tag. Now, where's the brain? Where does the actual combo logic live? Step 4, rewiring your attack gameplay ability.
This is where we modify that GA player melee attack ability we started with. This ability is going to be responsible for, well, kicking off the whole sequence and then critically staying active and reacting to those event.montage.combo events coming from the animation.
Okay, the guide says we need to replace the node we probably used before, the simple one for playing an animation, probably play montage and wait.
Yeah, play montage and wait is common for simple attacks. It does what it says, plays a montage, waits for it to finish, then the ability usually ends. Fire and forget.
But that's no good for a combo. We need the ability to stay alive, listen for events during the playback, and maybe even jump to different sections.
Precisely. Play montage and wait doesn't handle that interactive loop, so you rip that out and you replace it with a much more powerful GAS node. Play montage and wait for event.
Play montage and wait for event. That sounds purpose-built.
It really is. It's a cornerstone for complex animation interactions in GAS. So in your GA player melee attack blueprints graph, you add this node.
And how do you set it up?
You need to tell it a few key things. First, montage to play. You select our AMS combo asset here.
Okay, tell it which animation sequence to use.
Then, critically, the event tags pin. This is where you tell the node which gameplay tag events it should pay attention to while the montage is playing.
So we add our event.montage.combo tag here.
Exactly. Add event.montage.combo to that list. Now, this node, when active, will be specifically listening for that tag being broadcast by the character's ASC.
Got it. What about the outputs of this node? The execution pins.
Right. The wiring here is really important. It has several completion type outputs. On completed, if the montage plays all the way to the end. On interrupted, if something else stops it forcefully. On canceled, if the ability itself is canceled.
Okay, standard ways an ability might stop.
And the guide says correctly wire all of these on completed, on interrupted, on canceled directly to an end ability node.
Makes sense. If the combo finishes naturally or gets broken, the ability needs to clean itself up and end.
Absolutely vital. You don't want zombie abilities hanging around.
Okay, those are the exit ramps. But the really interesting one, the core of the combo processing within the ability, and this is maybe that non-obvious nugget for people new to this, it's the event received output pin.
That's the magic pin right there. Event received fires every single time our ansend gameplay event notify is hit on the animation timeline, because that notify sends the event.montage.combo tag, and this node is listening for exactly that tag.
The bridge. The animation timeline hitting the notify triggers execution out of this pin inside our ability graph. So what do we connect to event received?
This is where you put your actual gameplay consequence logic. For instance, your apply gameplay effect to target node to deal damage.
So the damage only happens when that specific notify fires, mediated by the ability listening for the event tag.
Precisely. The timing comes directly from the animation via the notify and the tag.
Okay, apply the damage, and then what? This is the really clever bit, right?
How does the ability stay alive for the next potential hit? Yes, this is the key. After you've run your damage logic, or whatever else you connect to event received, you take the execution wire coming out of that logic, and you drag it back and plug it into the input execution pin of the very same play montage and wait for event node.
Loop it back onto itself. That feels weird. Like it would restart the whole thing.
That does feel weird at first, but no, it doesn't restart the montage. Think of it like this. When play montage and wait for event first runs, it kicks off an underlying task within GAS. That task manages playing the montage and listens for the specified event tags.
Okay, an active task.
When the event received pin fires because the tag was detected, that task pauses the listening momentarily, runs whatever logic you connected the damage, and then by looping the execution back to the node's input, you're essentially telling that still active task, okay, I'm done handling this event, go back to managing the montage playback from where it currently is, and resume listening for the next event.montage.combo tag.
Ah, so it's not restarting the node, it's telling the ongoing task managed by the node to continue listening. The ability instance itself stays active, the montage keeps playing wherever it might be, and it's just ready for the next event signal from the animation.
Exactly. It creates this persistent listening loop. The ability activates once when the combo starts, begins the montage via this node, and then this node keeps the ability alive, processing events as they come in from the timeline until the montage finishes naturally or is interrupted, firing one of those other outlet pins that lead to end ability.
Wow. That's how it persists across multiple swings. It doesn't end after the first damage event. That is a really crucial detail.
It's fundamental to making this pattern work. The ability manages the active sequence and reacts to the animation's timing events. But notice, the ability isn't deciding if the player pressed the button in time.
Right. That's not its job here. Whose job is that?
That responsibility falls to the player character blueprint, which is step 5.
Perfect segue. Okay, step 5. Adding the combo rules and logic to the player character. So, the ability handles the active animation task and reacts to the timing events from the animation.
Well, the character receives the actual player input and needs to decide, based on timing and state, should this button press advance the combo or should it start a new one?
Okay, and the character needs some variables to keep track of this state, right? We already mentioned one.
Yep. We need that Boolean variable bInComboPeriod, the one that our AnimNotifyState notify state flips on and off based on the animation timeline. The character needs this variable defined within its blueprint.
So the character knows if the input window is currently open. What else does it need?
It also needs a simple integer variable. The guide suggests calling it combo counter, and it should default to 0.
Combo counter. To track which stage we're at. Like 0 for the first hit, 1 for the second, 2 for the third.
Exactly. It tracks which stage the player is currently attempting to reach or has just reached.
Okay, so bInComboPeriod, Boolean, and combo counter, integer. And we need some logic to use these.
Right. The guide recommends creating a new function inside the character blueprint to hold this logic. Let's call it advance combo. This function will get called every time the player hits the attack button.
Advance combo, okay. Let's walk through the logic inside this function. What's the first thing it does?
It starts immediately with a branch node, and the condition for this branch is our bInComboPeriod Boolean variable.
First check. Was the input actually pressed during a valid combo window, according to the animation timeline?
Precisely. Now, if bInComboPeriod is false, maybe the player pressed the button too early, too late, or no combo is active, the guide shows the false execution kin of the branch just does nothing. It leads nowhere.
So if the input wasn't in the window, this advance combo function just silently ignored the attempt to advance the combo. Makes sense.
But if bInComboPeriod is true, the player did press the button during the valid window, then execution goes down the true path.
Okay, what happens then?
The very first thing you do on the true path, according to the guide, is you immediately set bInComboPeriod back to false.
Set it false right away.
You need to consume that input window. Think about it. The player successfully used the window to trigger this advancement logic. You set it to false immediately to prevent weirdness, like if they somehow manage to click again super fast within the same original window. You don't want it triggering the advancement logic twice, one successful input per window.
Ah, okay. Consume the window state. Got it. What's next after setting it false?
Next, you use an increment in node on your combo counter variable. The player succeeded, so you bump the counter up. If it was 0, it becomes 1. If it was 1, it becomes 2. They're moving to the next stage.
Increment the counter. And then, how do we actually make the animation jump to the corresponding next swing?
You use a switch on in node. You feed the newly incremented combo counter variable into the selection pin of the switch.
A switch node. Perfect for if the counter's 1, do this. If it's 2, do that.
Exactly. So from the 1 output pin of the switch, meaning combo counter is now 1, they just completed the first hit and are trying for the second, you drag out an execution wire and call the function montage jump to section.
Montage jump to section. That sounds like what we need. Where do you call that function?
You usually call it on the character's skeletal mesh component, the component that's actually playing the animation montage.
Okay, call montage jump to section on the mesh. You need to tell it which section to jump to, right?
Yes, it has a section name input pin. So coming from pin 1 of the switch, you'd type in the name attack 2 into that section name parameter.
Got it. So counter becomes 1 jump to section attack 2.
Then from pin 2 of the switch, meaning combo counter is now 2, trying for the third hit, you do the same thing. Call montage jump to section on the mesh, but this time set the section name to attack 3.
And you'd add more pins for attack 4, attack 5, if you'd had a longer combo.
Exactly. So this advanced combo function on the character, which gets triggered by input only if bInComboPeriod is true, is the piece that figures out the next stage, combo counter, and then explicitly tells the currently playing Animation Montage, which the gameplay ability is managing, hey, jump to this specific name section now.
Okay, the division of labor is becoming really clear now. The character holds the overall state, bInComboPeriod, combo counter, and makes the input-driven decision, should we advance? If yes, it tells the animation where to jump using montage jump to section. The gameplay ability, GA player melee attack, is responsible for starting the montage initially, keeping itself alive using that play montage and wait for event loop, and listening for the event.tag. Montage.combo tag from the animation notifies to trigger things like damage.
Exactly. Character handles input state and directing the jump. Ability handles the active playback task and reacting to events from the animation itself. Clean separation.
Very nice. Okay, that leads perfectly into step 6. Tying it all together with the input handling, this is where the player actually pressing the button kicks everything off.
Right. You need to go to wherever your project handles the player's main attack input action event. Could be in the character blueprint, could be in the player controller. Depends on your setup.
The spot where when you press left mouse button or X button, something happens.
Exactly that spot. Now, the guide is very specific about the order of operations you need to connect to the triggered output pin of that input action event. This order is critical for making the whole system work correctly, for both starting and advancing the combo with the same button.
Okay, critical order. What is it?
First, immediately from the triggered pin, you call the advanced combo function that we just created on the player character.
Call advanced combo first.
Second, right after the advanced combo node finishes, you connect its execution output to your standard try activate ability by node. This is the normal GAS node you use to attempt to start a gameplay ability.
And you point that try activate ability node at our GA player melee attack ability, either by its class or maybe using a gameplay tag that identifies it?
Correct. So the order is input triggered doc, call advanced combo, call cry activate ability for GA player melee attack.
Okay, that seems simple enough, but why does that specific order work so well? The guide apparently explains this elegance.
It does, and it covers both scenarios beautifully. Let's take scenario 1. The player presses the attack button, but they are not currently in an active combo. Maybe they just started, or the last combo finished, or they waited too long. So the character's bInComboPeriod variable is false.
Okay, bInComboPeriod is false. Input fires.
First node called is advanced combo. Inside advanced combo, the first thing it does is check bInComboPeriod. Since it's false, the branch takes the false path, which does nothing. The function just finishes instantly.
Okay, advanced combo did nothing, execution moves on.
Execution flows to the second node. Try activate ability by for GA player melee attack. Now, because the character wasn't in a combo, that ability is currently inactive.
Right.
So try activate ability checks, sees the ability is inactive and can be started, and it succeeds. The GA player melee attack ability activates.
And inside the ability, it hits our play montage and wait for event node,
which starts playing the AMS word combo montage from the beginning, from the attack 1 section. The combo has successfully started.
Okay, scenario 1 makes perfect sense. Advanced combo does nothing, try activate ability succeeds, and starts the first attack. What about scenario 2?
Scenario 2. The player is currently in the middle of a combo, and they press the attack button again during the valid input window. So the AnimComboPeriod notify state was active, and the character's bInComboPeriod variable is currently true.
Okay, bInComboPeriod is true. Input fires.
First node called is advanced combo. Inside, the branch checks bInComboPeriod. It's true, so execution goes down the true path.
What happens on the true path again?
It immediately sets bInComboPeriod back to false, consumes the window, increments the combo counter, and then uses the switch on int to call montage jump to section, telling the currently playing montage to jump ahead to attack 2 or attack 3 or whatever the next section is.
Okay, so advanced combo successfully processes the advancement and tells the animation to jump ahead. Then advanced combo finishes.
Execution flows to the second node. Try activate ability by for GA player melee attack.
But wait. We established in step 4 that because the play montage and wait for event node is running and managing the montage playback, which just got told to jump sections but is still playing, the GA player melee attack ability instance is still active, right? It hasn't ended yet.
Exactly. The ability is already active because it's in that persistent listening loop.
So when try-activate ability gets called this time, the gameplay ability system checks, is GA player melee attack already active? It finds that, yes, it is currently active and running.
And because it's already active, and usually abilities can't be activated again if they're already running, unless configured otherwise, which isn't typical here, the try-activate ability call fails.
It fails, but that's okay.
It's not just, okay, it's exactly what we want to happen. We don't want to activate the ability again. That would restart the combo from attack 1. We just wanted to tell the currently active abilities montage to jump sections, which the advanced combo function already did before we even called try-activate ability. The failure of try-activate ability here is benign. It prevents a restart.
Whoa. Okay, that is elegant. Calling advanced combo first handles the advancement if applicable, and then calling try-activate ability second either starts the combo if it wasn't running or harmlessly fails if it was running, because advanced combo already did the work. That single sequence handles both cases.
It's a really neat pattern in GAS input handling. It leverages the state of the character, bInComboPeriod, and the active-inactive state of the ability itself to achieve the correct outcome with minimal fuss in the input graph. Saves you a lot of complex branching logic right there at the input event.
That's a huge takeaway. Okay, fantastic. We've built the structure, the components, the logic, the communication, and wired up the input trigger correctly. Now we just need to circle back to the very beginning, the visual foundation for step 7. Final assembly, placing the notifies precisely in the montage.
Exactly. This is where you actually put those custom notify blueprints we created, AnimComboPeriod and AnSend gameplay event, onto the timeline of our Amos word combo montage. This is where the designer's intent for timing really comes into play.
So open up Amos word combo again, find the notify track.
Yep. Now look at the part of the timeline corresponding to the attack 1 section, the first swing. You right-click on the notify track during that section and add our AnimComboPeriod state.
The yellow bar one.
Right. And you stretch that yellow bar out to cover the exact duration within attack 1 where you want the player to be allowed to press the button to trigger attack 2. The start, end, and length of this bar is your input window timing for that specific transition.
Okay, place and size the input window bar for attack 1. Then,
still within the attack 1 section's timeline, you scrub to the precise frame where the sword should ideally deal damage or have its impact. Right-click the notify track at that single frame and add our AnSend gameplay event notify.
the single point one that sends the event.montage.combo tag.
Exactly. That marks the damage moment for the first swing.
And then repeat for attack 2.
Yep. Find the attack 2 section on the timeline. Add the AnimComboPeriod state again, stretching its yellow bar over the duration where you want the player to input for attack 3. Then find the impact frame for the second swing and place the AnSend gameplay event notify there.
Okay, now what about the final attack, attack 3?
For attack 3, since it's the end of this particular combo chain, you only need to add the AnSend gameplay event notify at its impact frame.
Why no combo window? AnimComboPeriod.
Because there's no next attack in the sequence for the player to transition into. So there's no need to define an input window on the final hit. The combo naturally ends after this attack's impact and animation finishes.
Got it. So the combo window notify is only needed on attacks that can lead into another attack.
Exactly.
This step feels really crucial for the game's feel. Placing these notifies precisely defines how responsive the combo feels, how generous the timing windows are, and when the damage actually lands relative to the visuals.
Totally. It connects the technical system directly to the animator's or designer's timing intent, all visually on the timeline.
Okay. We followed all the steps, connected all the wires, placed the notifies. What's left?
The most important step, step 8, test.
Right. Got to make sure it actually works.
Yeah.
What should we be looking for? What are the expected outcomes?
The guide lists them clearly. First, just press the attack button once. You should see the first swing, attack 1 play. The GA player melee attack ability should become active.
Okay, start the combo.
Then, press the attack button again while that first swing is player, specifically during the time covered by the AnimComboPeriod yellow bar you placed. If it works, the animation should smoothly jump or blend into the attack 2 section. The ability should not restart.
Advance to the second hit. Got it.
Then, press again during the attack 2's combo window. Should smoothly transition to attack 3. You should also see your damage effects triggering when the AnimSend gameplay event markers are hit in each section.
Advance to the third hit. See damage. Okay.
Now let the full attack 3 animation play out. Since it has no combo window and is the end, the montage should finish, and the GA player melee attack ability should automatically end because onCompleted was wired to end ability.
Combo completes and ability cleans up. Good.
And finally, test the failure case. Start the combo with one press, then wait. Let the combo window, AnimComboPeriod bar, pass completely, then press the attack button again.
What should happen then?
It should not advance to attack 2. Because you pressed outside the window, the advanced combo function should have done nothing. Its bInComboPeriod check failed, and the subsequent try-activate ability call should have succeeded because the original ability likely ended when the window closed or shortly after, causing the combo to start all over again from attack 1.
Ah, resets if you're too slow. That's the expected behavior.
That's the expected behavior for this setup.
And if something's wrong, if it doesn't advance or always restarts or damage doesn't happen, where do you look?
You backtrack through the steps. Are the notifies placed correctly in the montage? Is the AnimComboPeriod defining the window you expect? Is AnSend gameplay event sending the exact event.montage.combo tag? Is the play a montage and wait for event node in the ability listening for that same tag? Crucially, is the execution from event received looped back to the node's input? Is the bInComboPeriod Boolean on the character actually being set to true and false by the notify state? You can add print string nodes temporarily to check variable values. Is the advanced combo logic checking the Boolean correctly and calling montage jump to section with the right section names? Is the input handler definitely calling advanced combo before try activate ability?
Lots of potential points of failure, but they're all linked in that chain.
Exactly, and the GAS debugger tool in Unreal is your friend here. It lets you see which abilities are active, which tags are present, which events are firing. It can help pinpoint where the breakdown is happening.
Debugging tools are essential, but assuming the tests pass,
then congratulations, you've successfully followed the guide piece by piece and implemented a pretty robust, data-driven, multi-stage melee combo system using Lyra and GAS. It's a solid pattern.
it really does feel like a well-structured approach leveraging the strengths of GAS.
It is. It breaks the problem down. Animation sequence, timing windows, event triggers, state management, input handling, and assigns responsibilities to the right places. Montage, notifies, tags, ability, character, they all work together.
So just to quickly recap the journey for everyone listening, we tackled that common challenge, building a fluid melee combo. We followed this detailed guide, starting with creating the animation montage, AMS chord combo, and defining named sections attack 1, attack 2, attack 3 within it.
Then we built our custom timing tools, the AnimComboPeriod and AnimNotifyState to control the bInComboPeriod Boolean on the character for the input window, and the AnSend gameplay event AnimNotify to fire off a specific gameplay tag, event.montage.combo, at impact moments.
We defined that crucial event.montage.combo tag in the project settings to act as the communication code word.
We then modified our basic GA player melee attack ability, swapping out simple playback for the powerful play montage and wait for event node. We configured it to listen for our event tag and critically looped its event received output back to its own input to keep the ability alive and listening throughout the sequence.
Next, we added the state variables, bInComboPeriod combo counter, and the core decision logic, advanced combo function, to the player character blueprint. This function checks the input window, consumes it, increments the counter, and tells the montage which section to jump to.
We wired up the player's attack input action, ensuring the critical order. Call advanced combo first, then try activate ability. This elegantly handles both starting and advancing the combo.
And finally, we went back to the AMS sword combo montage and precisely placed our custom AnimComboPeriod duration and AnSend gameplay event notifies onto the timeline, dictating the exact gameplay timing.
It really demonstrates how, starting from that Larragee's base, you can build something fairly complex like this, step by step, in a way that's organized, data-driven, and easier to debug than trying to hack it all together in one place.
Absolutely. And now that you have this linear 3-hit combo working, built on this pattern, the foundation is there. You can start thinking bigger. Right?
Oh, definitely. This guide showed us one path, a simple sequence, but the structure itself is flexible. Think about that switch on in node in the character's advanced combo function.
Yeah.
Right now, it just goes 1 attack 2, 2 attack 3. What if you had, say, a heavy attack button that also called advanced combo? Maybe inside advanced combo, you check which button was pressed. If it was the heavy attack during the window, maybe you increment the counter differently, or maybe the switch node sends you to a different section name, like attack 2 heavy instead of attack 2.
Ooh, branching combos. Based on different inputs during the same window. That could get really interesting. Building complex combo trees.
Exactly. Or think about those Anson gameplay event notifies. We use them just to trigger damage logic via the tag, but what if you added more functionality to that notify blueprint?
Like what?
Maybe add pins to it where a designer could specify a particle effect to spawn or a sound cue to play right when that notify hits. The notify could then not only send the gameplay event tag, but also directly trigger those specific effects.
Ah, so your damage, your visual effects, your sound effects, all perfectly synchronized because they're triggered by the same notify, plays precisely on the animation timeline, all mediated through GAS.
You got it. The foundation is incredibly powerful. You've got animation playback, input windows, state tracking, event handling, all wired together through GAS. The guide gave us the blueprint for a basic combo. But using these same building blocks, these same patterns, what other kinds of responsive, layered, complex combat interactions could you build on top of this?